Okay guys, we are looking at video number 3 and we're looking at the 6.2D. I can order a set of rational numbers arising from real world and mathematical situations. So the question says the table shows the same amount of time 4 students practiced, or shows the amount of time that 4 students practiced the trumpet in one day. List the students in order from least amount of practice time to the greatest amount of practice time. So guys, to be able to go from least to greatest, we have to have the same form of numbers. Now they all are fractions, so we can change them all to the same denominator if we wanted to, and 3, 2, and 4 all go into 12, so that would be really easy. I'll do that last, but what we usually do or typically do when we are ordering rational numbers is we change them all to decimals, so let's go ahead and do that. Well, I can tell already that every single one of our numbers has one whole, so I cannot just look at the one and determine which one is bigger and which one is smaller, so I have to look at my fractions. So to write the decimal, all we now have to look at is our actual fraction. So the first thing I'm going to do is 2 divided by 3. 3 goes into 2, 0 times. So I add a decimal and I take it up to the top, and then I add a 0. 3 can go into 20 6 times, which is 18. 6 times 3 is 18. When I subtract, I get 2. I take a 0 and I bring it down. 3 goes into 20 6 times. 6 times 3 is 18. I subtract and I get a 2. And if you notice my pattern with getting 2 left over every time, that I know that my 6's repeat, so we give it the line above the 6's that they're repeating. So when we put our decimal over here, we're going to put 1 and 66 repeating. Then we have 1.5. I already know that 1.5 is 1.5. If you want to work it out, you are more than welcome to, but I already know that 1 divided by 2 is 0.5. So that's 1.5, so 1.5. Because the number above it already has 2 decimal places, I want to make sure that I give myself 2 decimal places to work with so that when I'm comparing, it makes it easier. When I look at 1 and 1/4, I already know that 1/4 is 0.25 because a fourth of a dollar is a quarter, and a quarter is 25 cents. If you want to work it out, we can come over here and we can do 4 into 1, or 1 divided by 4. 4 cannot go into 1, so I add a decimal and bring it up. 4 goes into 10 2 times, which is 8. 10 minus 8 is 2, so I add another 0. 4 goes into 25 times. 5 times 4 is 20, and I get 0, so I do get that 0.25, just like that. So now we're going to look at 1 and 7/12, and that 7/12 is something that we haven't seen a lot of, but we're going to go ahead and do it. 7 divided by 12. 12 does not go into 7, so I add a 0, add a decimal. 12 does go into 70. It goes into 75 times. 5 times 12 is 60. 70 minus 60 is 10, and I can add a 0 and bring it down. 12 goes into 100 8 times. 8 times 12 is 96, and when I subtract, I get 4. Now, we can keep going, because if we keep going, you'll realize eventually that this will just keep repeating, but it'll be a different number that repeats. But since all of my other answers only had 2 decimal places, I can stop after 2 decimal places and say that this is about 1.58. And then when I can order my numbers, I need to go least to greatest, so I pretend that the decimal isn't there. Or I can leave the decimal there, but we need to say it that this is 125 hundredths. So it's 125, 150, 166, and 158. So which one of those is the smallest? Well, it's the 125, so Ryan would be first because he practiced the least. Then it would be the 50, so that would be Gus. Then it would be the 58, which would have been Jacob. And last, the person that did the most practice was Cole. I hope that helped you out on that one, guys. So let's go ahead and look at the next question. It says, during 1 month, 4 trees at a nursery increased in height at the rates shown below. So we have 8%, 1/12, 16%, and 1/20. And it wants us to list the numbers in order from greatest to least. So I'm going to start out by saying that you can change these to whatever form that you want. You can make them all fractions, you can make them all percents, or you can make them all decimals. My advice would be to change them all to decimals, but you can do whichever you want. So let's start with 8%. The first thing I'm going to do over here, though, is I'm going to say that I want 8%. I'm going to make a table for myself. So 8%, I have 1/12, I have 16%, and I have 1/20. Because I want a table that kind of looks like the question that I did up here so that I can easily see how these numbers compare to each other. So let's start with 8%. How do I change a percent to a decimal? Well, to change a percent to a decimal, I divide by 100. I know 100 cannot go into 8. It cannot go into 80, but it can go into 800. 8 times 100 is 800, and I get 0 when I subtract. So my answer is 0.08. When I look at my next one, I have 1/12. Well, to change a fraction to a decimal, we have to divide. So I get 12 into 1, or 1 divided by 12. 12 cannot go into 1. So I'd add a decimal, add a 0. 12 cannot go into 10. But 12 can go into 100 eight times, and that gives me 96. 100 minus 96 is 4. That because this isn't 0, I add a 0, bring it down. 12 goes into 40 3 times, which is 36, and I get a 4 again. So you'll notice that the 4 is going to repeat. So the 3 is going to repeat, not the 8, just the 3. So the 8 stands alone, and then the 3, excuse me guys, the 3 gets the line above it. So when I come over here to my table under 1/12, I'm going to put 0.083 repeating. And because this has 3 decimal places, I need a number after the 8 to give it the 3 decimal places as well. So I do a place value holder, which is that 0. Now we're looking at 16%, and just like when we changed 8% to a decimal, to change 16% to a decimal, we have to divide by 100. 100 does not go into 1, it does not go into 16, so I add a decimal, add a 0. 100 does go into 161 time. I subtract and get 60, and then I bring down this 0. 100 goes into 600 6 times. 6 times 100 is 600, and I get 0 when I subtract. So my answer is 0.16. Because there are 3 decimal places up already established, I do have to give it a place value holder, which is that 0. And now I have one more left, and it's the 1 divided by 20, or 1/20. So 1 divided by 20. 20 does not go into 1. So I add a 0, add a decimal, add a 0. 20 cannot go into 10. So I add another 0. 20 can go into 100 5 times. 20 times 5 is 100. So when I subtract, I get 0. So my answer over here is 0.05. But just like before, because I need 3 decimal places, I need 3 decimal places. So now when I look at my numbers over here, I can pretend like the decimals don't exist. And then what am I looking at? Well, I have 50, 80, 83, and 160. Because they all have the same number of place values, or they have the same number of decimal places, I can look at it like this. That is why it is important that we put placeholders when we need to compare numbers. So when I'm looking at this, I get that this number would be the greatest, then this one, then this one, and then this one. Guys, I hope this video helped, and stay tuned for the next installment.